Okay, fine. So here we have cubic functions. Whenever we have cubic curve and we are looking the turning points, we will find two turning points. One is minimum, one is maximum. So, for example, you have the curve of cubic is like that. One is minimum point, one is maximum point, and both minimum and maximum point stationary point is always zero. So when you have positive x cube, it will come from right side, and when we have negative x cube, it will come from left side. Anyway, see one question from here, this exercise. Let's suppose we have y is equal to x cube plus 3x squared minus 9x plus 5. And the first thing we are looking derivative. So differentiate with respect to x, dy over dx, which is equal, if I write direct answer because we solved many questions, so it is 3x squared, and the derivative of x squared is 2x, derivative of x is 1, and derivative of 5 is 0. So we have dy over dx equal 3x squared plus 3 twos are 6x minus 9. So remember that as we are looking turning points, so for that or for stationary point, we can say that derivative dy over dx equals 0. So this equation becomes 3x squared plus 6x minus 9 equals 0. Remember that this is quadratic equation, and when we have quadratic, we apply sum and product factorization concept, completing square method, or quadratic formula. So as you can see that they all are divisible by 3. So divide by 3, we will get x square plus 2x minus 3 equals 0. I divide throughout the equation by 3. Now we will think about factorization. For example, if I think about product, my product is here minus 3x squared. And if I think about sum, that is 2x. So we need two numbers. If we multiply, it must be 3. And if we add and subtract, it must be equal to 2. So 3 ones are 3, 3 minus 1, 2. That works. If we write x squared plus 3x minus 1x, that gives us exactly 2x, and if you multiply it is product, so it works. So here we will find two numbers, one is x plus 3, or first we factorize x plus 3, and x plus 3 is common, so we are looking x is equal to minus 3 and x is equal to plus 1. So remember that we have 2 points, and these 2 points we have to replace back in the original equation. So we will find out 2 points. So first I will check at x is equal to minus 3. At x is equal to minus 3, y is basically y equation is what? X cubed plus 3x square minus 9x plus 5. So if I replace minus 3 in this equation or curve, it would be 3 minus 3 whole square minus 9 into minus 3 plus 5. That gives me minus 27. 3 threes are 9. 9 multiplied by 3 plus 27, and minus minus plus 27 and plus 5. So these first two cancel. 27 plus 5 gives us 32. So this is 1 point when x is minus 3 and y is 32. Remember that till now we don't know this is minimum or maximum. That is another rule I will mention. But first we find out what is the value at x is equal to 1. Now, now at x is equal to 1, what is the value of this curve? So I will replace 1 cube plus 3 into 1 square minus 9 into 1 plus 5. So that gives me 1 plus 3 minus 9 plus 5, which gives us 3 plus 1, 4 minus 9 plus 5. So 4 minus 5, 4 minus 9 minus 5 plus 5. I hope so it's 0. It means we have another point when x is 1, y is 0. So we have 2 points. Now we will say which one is minimum and which one is maximum. So remember that it's clearly when y value is bigger, that looks like maximum, but there is a rule. We have to find second derivative. We already know that the first derivative is what? So if I say, and remember that the rule is what? If second derivative d square y over dx square is less than 0, then the points are maximum. Then points are maximum. If second derivative at the given point, for example, at the given points are here minus 3 and 1. If the second derivative is greater than 0 at that point, which we are looking 1 or minus 3, if it is greater than 0, then point are minimum. Okay, always opposite. For example, if I check the second derivative of this one 3x square, this one 3x square plus 6x minus 9, it gives me what? So this one d square y over dx square. I'm writing direct answer, okay? 3x square gives us 3 twos are 6x. 6x plus 6 because derivative of 1 is 0 and derivative of 9 is 0. It means we are getting 6x plus 6. This is second derivative. Now we will check this second derivative at x is equal to minus 3. So d square y over dx square, I'm checking x is equal to minus 3. So 6 into minus 3 plus 6, that gives me minus 18 plus 6, which gives us minus 12. And minus 12 is less than 0. It means if second derivative is less than 0, the points minus 3 comma 22 is maximum. This is turning point, and we can say that maximum also. Hence, you can say that minus 3 comma 32, that turning point is maximum, maximum point or required turning point. And we can check at x is equal to 1 also, okay? I don't have place to solve, so I'm checking here, okay? See, if I check at x is equal to 1 second derivative, we already know that second derivative is what? D square y over dx square. I'm checking at x is equal to 1 equal what? We have 6 bracket open 1 plus 6. So 6 plus 6, 12. 12 is greater than 0. So if second derivative is greater than 0, it means the required point, which is 1 comma 0, is minimum. So we find out the nature of the roots also, which one is maximum and which one is minimum. I hope so it is clear. We found two turning points of the cubic curve. One is maximum and one is minimum. And we take the help of second derivative as well. I hope so it is clear. We have another question, which is an open box is made from the thin square metal sheet measuring 10 centimeter by 10 centimeter, and four squares of side x are cut away and the remaining four sides are folded upward to make an open box of depth x. So if we see depth is given, which is x, and the other sides, for example, you want to check from here to here, the length uh, is what? So total length is 10. So from this point to here, x, this point to here, x, because we know from here. So I'm looking only this much length. That means 10 minus 2x. So I have to take or cut away this 2x's, okay? Means actually it is 10 minus x minus x. So we can say that 10 minus 2x. So same way other side, like this side, It's square, so all sides are equal, in other words. So this is also 10 minus 2x, and the height is given. So whenever you find the volume of cube, we need side, length, width, and height, three things. So the base length and width, we have 10 minus 2x, 10 minus 2x, and the depth or height is x. So what they want, show that the volume V of the box is given by this. They mentioned the answer. We will try to justify this answer. Okay. So see, if I try this one, I need a color. Okay. So we know, we can say that volume is equal to length multiply length, because all sides are not equal. So you can say that length, width, and height. But here we have two lengths are same. 10 minus 2x, and again 10 minus 2x, and the rest depth or height is x. So I will solve first these two parts, means 10 multiplied by 10, 100. 10 multiplied 2x gives me 20x. Again 2 multiplied 10 gives me 20x, and minus minus plus 4x squared, bracket close, and x. Next step, we can say that 100 minus 40x and plus 4x squared and multiply by x. If we multiply x throughout the equation, right side, we have 100x minus 40 x power 2 plus 4x cubed. This is our required volume, and we show that. They also write the same thing, 100x minus 40x squared plus 4x cubed. So after this, we will move on second part, and in second part, they want us to derive with respect to x. So for that, d part, we have to differentiate dv over dx. So d over dx, 100x minus 40x squared plus 4x cubed. So if I apply the derivative, now all of you know that the derivative of x is 1. If I apply the derivative on x, so that gives me 1. And derivative of x squared is 2x, and the derivative of x cube is 3x power 2. Subtract 1 from the power, okay? And next step, we can say that it is 100 minus 40 multiplied by 2, 80x, plus 4 multiplied by 3, 12x squared. This is the required derivative and answer of B part. Now for maximum volume, we know that it's a cubic curve, and in cubic curve we have maximum and minimum 2 points, but we are looking only maximum volume. Okay, for which value? So for that, if we have cubic curve, and cubic curve at maximum point, we have straight line, our derivative is 0. So we can say that for stationary point over dv over dx equals 0, then required equation becomes what? It is 100 minus 80x plus 12x squared equals 0. We can rearrange 12x squared minus 80x plus 100 is equal to 0. All are divisible by 4. If you think carefully, all are divisible by 4. So we have 3x squared minus 80 divided by 4, 20x. 100 divided by 4 gives us 25. So this is quadratic. You can apply factorization concept or quadratic formula, or we have another way to solve these questions. Straight away, I'm going to teach you because these questions are so long. So you can use calculator also. For example, you press mod and equation, okay, 5, and press 3. Remember that over a value is what? A is 3, B is negative 20, and C is 25. So replace all these three values here. A is 3 equal, B is -20, and then C is plus 25. So I'm getting one value I'm getting 5, x is equal to 5, and the second value, because it's quadratic, so we must have two answers, and the second value I'm getting 5 over 3. Okay, so we can say that 5 over 3, x is equal to 5 over 3. So one value will give us maximum, one minimum, that we have to figure it out. So see here, for x is equal to 5, if we replace back in the equation, which is y or v equal 100x minus 40x squared plus 4x cubed, so what is it? So actually we are looking the maximum value. So let's have a look. If we check at x is equal to 5, so at x is equal to 5, v becomes what? 100 into 5 minus 45 squared plus 4 5 cube means 500, and 5 5s are 25. So 25 multiplied by 40. If I check 25 multiplied by 40, that gives me 1000. This is 1000. And 5 cube means 125. 125 multiplied by 4, it gives us 500. So look, 500, 500, 1000, 1000, and 1000 minus 1000 cancel 0. So this does not make sense, but anyway, we write when 5 we have 0. It's not look like maximum. We check at second value 5 over 3. Okay, now I'm checking at x is equal to 5 over 3 over v value. Our maximum volume becomes what or how much? 100 bracket open 5 over 3 minus 45 over 2 whole square and plus 4 5 over, sorry, 5 over 3, not 2, 5 over 3 whole cube. So same value if you put in the calculator and check straight away once. For example, I'm checking here. So see here, I need a normal 1, and I'm plotting these values. 100 bracket open 5 over 3, 5 over 3 bracket closed, and then we have minus 40 bracket open. We have 5 over 3 bracket close, and it is square. Okay, press square, and then we have plus 4 bracket open we have 5 over 3 bracket close, power is what? Q. And if you press Q, press equal, we are getting 2000 over 27. So V equal 2000, and remember this is maximum. Of course the previous one is 0, so this is bigger than 0, so this is our maximum value. When x is 5 over 3, we are getting volume 2000 divided by 27. So this is required turning point as well as and maximum point also. So I hope so it is clear. They want us the maximum value, calculate the maximum value of the box. So this is the maximum value, 2000 over 27. That is the required maximum value. Now we will discuss few questions related to displacement, velocity, and acceleration, and how to utilize that concept of derivative in these type of questions. So first question, the displacement, which represent as meter, which is also called distance, of a particle after t seconds from a fixed point O, is given by s is equal to 10t squared minus 30t plus 1. So they want us after a time of 2 seconds, find the particle's velocity and acceleration. So when we try to find out the derivative, so ds over dt, that represent exactly velocity. So Let's have a look. We have S is equal to 10t squared minus 30t plus 1. So if I say the derivative of this with respect to differentiate with respect to t, means ds over dt. That gives me right hand side also d over dt, which is 10t squared minus 30t plus 1. So if I apply the derivative inside it, I will apply on the function, okay? Means when you apply on t square, bring down the power, subtract 1 from the power. So it is 2t, and the derivative of t is 1 and the derivative of 1 is 0. Means we are getting 10 to the 20t minus 30. This is ds over dt, which represent velocity or v. Rate of change of distance with respect to our displacement with respect to time is called velocity. So this is v, and then they ask find v after 2 seconds. Okay, that we will find later. We check b part also. Or if you are checking first a to complete a, check v at s is equal to, no, t is equal to 2 seconds. T is equal to 2 seconds, means 20 into 2 minus 30, which gives us 40 minus 30, which is equal 10 meter per second. Now, if we have v is equal to 20t minus 30, so apply the derivative again, differentiate again with respect to t, which gives me dv over dt. It is equal d over dt, bracket open, 20t minus 30. So remember that dv over dt means rate of change of velocity with respect to time is called acceleration. So we can say that this is acceleration, which is equal 20 into 1 minus 30, sorry, 30 becomes 0 because the derivative of constant is 0. So we have 20. So we cannot change, we cannot check at after 2 because there is no t right now. So this is straight away your answer, which is meter per second square. And this is acceleration. I hope so it is clear. We find acceleration as well as velocity. So these are the answers. Any questions? We try one question from the revision. Find the gradient of the tangent of for y is equal to 2x cubed plus x square minus 4x plus 1 at x is equal to 1. So we have to differentiate first. Y is equal to 2x cubed plus x square minus 4x plus 1. So first of all, we will differentiate with respect to x. So it is dy over dx. D over dx, we have 2x cubed plus x square minus 4x plus 1. And if we apply the derivative, so it would be 2 d over dx x cube. I'm applying on function, okay? Means variable. Square minus 4 d over dx x, and derivative of constant. Means we are getting 2 multiply 3x power 2. And plus derivative of x square is 2x, derivative of x is 1, derivative of constant is 0. So our last answer is 6x power 2 plus 2x minus 4. But don't stop here. They are saying that what is your gradient at x is equal to 1. So dy over dx at x is equal to 1. It becomes 6 into 1 square plus 2 into 1 minus 4. That gives us 6 plus 2 minus 4, 8 minus 4, which is equal 4. So this is your last answer. I hope so it is clear. So if we try one more question related to turning point, so see, have a look, question number 3, y is equal to 2, bracket open, x plus 1, x minus 1. So first x, basically this is difference of two squares. So you can straight away x square minus 1 or 2x square minus 2. Remember that when the coefficient of x square is positive, we always have a U shape, means you will get minimum point. What is the derivative dy over dx, which gives us 4x minus 0. So dy over dx is equal to 4x. And we will check this one for turning point. So for turning point, over derivative must be 0, means 4x is equal to 0. So x is equal to 0 over 4 means x is 0. So when x is equal to 0, what is our original curve, or this one? Y becomes 2 into 0 square minus 2. So that means we have minus 2. So we are getting the point 0 comma minus 2. This is our minimum point or turning point. Turning point or minimum point.